Welcome back to section 8.3. We've talked about absolute value equations. We've talked about absolute value inequalities. The last thing I want to do is talk about some special cases, okay? In general, absolute values should be positive values, so greater than or equal to 0. So if you have an absolute value that equals 0, you're only going to get one answer because opposite of 0 is still 0. So it doesn't really become a compound inequality or two equations. You just get one answer and it's 1 point for it equaling 0. The other thing is that absolute values are never going to be negative. You don't have negative distances from 0 on the number line. So if you have an absolute value greater than a negative number, well, of course it's greater than a negative number. It will always be greater than a negative number. So every solution will work for that one. And the absolute value will never be less than a negative number. And less than a negative number would just be a bigger negative number. So it's never going to be on that side of the number line in general, okay? So those are your special cases where you might get all real numbers, or you might get no solution, or you might just get one solution instead of a bunch. So let's do a few examples of these, okay? In general, the red flags that should come up is negative numbers or 0, okay? So let's do a couple of special cases with equations. In example 6. So first one I have for us is the absolute value of 6x plus 7 is equal to negative 5. So that negative 5 should come up with a red flag because wait a second, absolute values can't be negative. Sometimes you guys want to jump ahead and write your two equations. There are no two equations to make because it's equal to a negative, and absolute values can't be negative. So stop yourself right there and think, that can't happen. We're never going to get a negative value from an absolute value. This is no solution. So you can stop right there. Don't do lots and lots of work for nothing. It's no solution. Okay, we can tell right from the very beginning because we have this negative value. In B, I've got the absolute value of 1/4 x minus 3 equals 0. So 0 should be a small red flag, nothing too terrible. But the absolute value equal to 0, there's only one option. You're not going to have two different choices. So we're only going to have one equation. 1/4 x minus 3 equals 0. It's the only way to get 0 from an absolute value is to put 0 in. Okay? Then we'll solve our one equation. So we'll add 3 to both sides. So 1/4 x equals 3. And then to simplify that 1/4 x, technically you're dividing both sides by 1/4, which is the same thing as multiplying by 4 over 1. So these will divide out. And 3 times 4 is 12. So we just have one answer when the absolute value equals 0, and our one answer is x equals 12. All right, let's do some inequalities with special cases. So in example 7, the first one I have for us is the absolute value of x is greater than negative 4. And again, that negative should set off some sort of a red flag for you because absolute values aren't going to be negative. So when you say that the absolute value is greater than a negative number, well, of course it is. Absolute values are always positives, and positives are always bigger than negative numbers. So no matter what x you put in, that's going to be a true statement. So basically, this is always true, which means that our answer is going to be all real numbers. Okay? Now, what does all real numbers look like on a number line? It looks like a line on top of your number line. It's everything, both directions. What does this look like in interval notation to put all real numbers? Well, how far left does it go? It keeps going forever in the negative direction, so that's negative infinity. How far to the right does it go? It keeps going forever in the positive direction, so that's positive infinity. So negative infinity to positive infinity is the interval notation of all real numbers. So that's what the graph looks like. That's what the interval notation looks like. All right, the next one in part B is the absolute value of t minus 10 minus 2 is less than or equal to negative 3. First thing, of course, is the absolute value is not by itself yet, so I should definitely deal with that first. I'm going to add 2 to both sides so that the absolute value is by itself. Then I have the absolute value of t minus 10 is less than or equal to -1. I still have a negative over here. That should pull up all kinds of red flags because absolute values aren't negative. So how often is the absolute value going to be less than or equal to a negative number? Well, it's not. It's not going to equal -1, and it's certainly not going to be less than -1 because those would be bigger negative numbers. So that doesn't happen. That's never going to be true. So this is no solution. And no solution would just look like a blank graph. There's not really a pretty interval notation for no solution. There is the set notation where you have the empty set if you want to do that. Okay? Let's see, last one I have over here is part C. The absolute value of 2x minus 5 is less than or equal to 0. Alright, well 0 should be another one where we kind of have to stop and think. So absolute values are never going to be less than 0 because those would be negative numbers and absolute values aren't negative, but they can be equal to 0. So this one is actually going to turn from an inequality to an equation because there's only one way that we're going to satisfy this, and it's going to be if the absolute value equals 0. That's the only time it works. So we're going to have 2x minus 5 equals 0. That is the only solution to this entire inequality, okay? So to solve our equation, we'll add 5 to both sides, so 2x equals 5. And we'll divide both sides by 2, so x would be 5 halves, or 2.5 if you like mixed numbers. Okay, so that's what these special cases look like. Now it's your all's turn. You get to try one and show me how much you've learned.